Good morning. Today we're talking about observing motion and distance and displacement, the differences and the similarities. So right now I want you to think about this question. How can you tell when something is moving? I think we kind of take for granted that we know when something's moving, but what is it that allows us to tell when it's moving? Think about that for a moment. Alright, so to observe the motion of an object, we have to first observe the object in relation to some other object that stays still. This is called a stationary object. So we need both the thing that's moving and the stationary object in order to truly tell that it's moving. So the stationary object is what we call a reference point. We sometimes call this a frame of reference or a reference frame. So in this picture, and these two pictures actually, you see a mountain in the background, and that is the reference point to know that the two pictures were taken at different times, and therefore the balloon is moving. And often we can use earth features as a reference point, such as mountains or trees, and things like that. When an object changes position in comparison to a reference point, we can verify that the object is indeed in motion. So now it's your turn to take this knowledge you just gained of motion to use. On your worksheet, you have a couple pictures where you're going to identify what is in motion and what is the reference point for each of the pictures. Now I know nothing's actually moving. Pictures are static, they don't move like videos do. But you can tell what's moving because you can also identify a reference point. So take a couple minutes and complete that part of your worksheet. And by the way, there may be more than one reference point. So press pause, complete your worksheet, you do, and then come back and press play. Okay, so hopefully you enjoyed that little exercise. We'll look at that in class. So distance measures the path taken. So now we're getting into the difference between distance and displacement. And in addition to having a direction, we also need to know how far an object moves in order to accurately describe its motion. So to measure distance, we measure the actual path that it takes. Now, this is referencing Chatterteeth Toys. You're going to see that example tomorrow. So instead of saying did here, it should say like you will. So think about this. If you started at your home, you wandered around your neighborhood, changed direction a few times, and you have a string that follows your path, that string would be as long as the path that you traveled, or the distance. Now displacement is a little bit different. Displacement is the change of an object's direction. Or should I say position. So here we have a starting point in the green, and we have a stop point. Okay, so this straight line is the distance. It's also the displacement. If you take a second string after you've walked around your neighborhood, go back to that analogy, and you stretch it in a straight line between your starting point and your stopping point, that distance would measure your actual displacement rather than your distance. So here's an example. The blue line represents your path around the neighborhood. The green arrow represents your displacement. So as you travel a far distance to get to this point. But if you put a string that goes straight from the starting point over here to the ending point over here, you'll find that the displacement is not nearly as far as the distance. So there are two main differences between distance and displacement. One is straightness. Displacement is straight, distance is not necessarily straight, although distance can be straight. And the other is direction. So distance can be a straight line, but it doesn't have to be, whereas displacement must be a straight line. You cannot measure displacement with anything other than a straight line. Otherwise, you're measuring a distance. So distance is typically longer than the actual distance, unless the path traveled is a straight line. It's also usually longer than the displacement. Displacement is typically shorter than the actual distance unless the path traveled is a straight line. Again. So that last section should be straight line. Now, displacement must be in a particular direction. The distance between your home and, well, you wouldn't be going to school. The distance between your home and, say, your local school may be 12 blocks, but that information doesn't indicate whether you're going towards or away from school. So, displacement must always indicate the direction, such as 12 blocks toward the school. That gives us a direction. So, it's your turn. Compare and contrast the displacement and distance on your worksheet. You'll find a couple tables at the end of your worksheet where you can list the similarities of each and the differences of each. Pause the video now to complete that. When you're finished, come back. Okay, now that you've finished the differences and similarities comparison tables, your last thing to do is the exit ticket. So at the bottom of your worksheet, you're going to explain the relationship between motion and a frame of reference.